Welcome to Homework Lib.
Hi, so in this case with the following information we're going to find the change of the freezing temperature, the molality of our solution, the moles of benzoic acid, the molecular weight of benzoic acid, and we're going to compare with the exact result. So first of all, the change of the freezing temperature is going to be equal to the freezing temperature of the mixture minus the freezing temperature of the pure substance, in this case the pure lauric acid. This is going to be equal to 38 minus 43, which is minus 5 degrees Celsius. Now, with this information, we want to calculate the molality of the solution. Remember that the change of freezing temperature is equal to Kf times the molality. In this case, the value for Kf would be the value for lauric acid, which corresponds to 3.9 degrees Celsius, kilogram per mole. Thus, the molality would be equal to delta Tf divided by Kf, which is going to give us minus 5 degrees Celsius. Sorry, over here with a minus, and also minus over here, divided by minus the molality, which is, Kf, which is 3.9 kilograms per mole, which is going to give us a molality of 0.78, equal to 0.78 mole per kilogram. Let me just erase this thing over here because it got messed up for some reason. So 0.78 moles per kilogram. This is going to be the molality of the solution. Now we're done with the first parts. We want to know the moles of benzoic acid. The mole of benzoic acid is going to be equal to the molality times the mass of the solvent, which is going to be lauric acid. So moles of benzoic acid per kilogram. We are going to have in the sample 4.1 grams of lauric acid. So 4.1 grams. And we need to employ a conversion factor, 4 grams to kilograms. So we know that 1,000 grams is equal to 1 kilogram, which gives us 3.198 times 10 to the minus 3 mole of benzoic acid. With this, we can calculate the molecular weight, which is going to be equal to the mass of benzoic acid divided by the amount of mole. In this case, we're going to have 0.5 grams divided by 3.198 times 10 to the minus 3 mole, which gives us 156.35 grams per mole. This is going to be the experimental result. Now we can compare this with the theoretical value for benzoic acid, which the accepted result is a molecular weight of 122.12 grams per mole. So, as you can see, the percent of error is going to be quite high. So the percent error is going to be equal to experimental minus theoretical in absolute value divided by theoretical times 100. So 156.35 minus 122.12, which is going to give us a percent error of the 28.03%. And with that, it would be all. Thank you very much and have a good one.